if you mean by making a choice, of course we have free will, right? Because we always make choices. Now, if you mean making a choice that's not governed by the laws of physics or by the processes in your brain, well, scientifically, of course, we don't have free will. Because, of course, everything we do is governed by the laws of physics. So some people, I think, equate free will with essentially magic or supernatural beliefs or a soul, and that there's something else that's making those decisions. So scientifically, we can say, no, that's not the case. So if you're going to define free will by something that's governing your decisions that's outside of science or outside of physics and neuroscience, then no, we can say we don't have free will.
Hello guys, welcome to this episode of Little Brains Big Topics. This is Mohammed, your host. For this episode, we're honored to have Dean Buonomano. So I'm going to tell you guys who he is and the topics we covered in this episode. So Dean Buonomano is an American neuroscientist, psychologist, and author. He's a professor at UCLA whose research focuses on neurocomputation and how the brain tells time. Buonomano has been described as one of the first neuroscientists to begin to ask how the human brain encodes time, and has been published in various scientific journals. He is the author of 2 books, Brain Bugs: How the Brain's Flaws Shape Our Lives, and Your Brain is a Time Machine: The Neuroscience and Physics of Time. Buonomano's first book, Brain Bugs, examines the human brain's functional strengths and weaknesses, ultimately attributing some of the brain's bugs or flaws to evolution. In this episode of the podcast, our main focus is his second book, which is Your Brain is a Time Machine. So I do ask him about why he wrote the book, and then I ask him questions about his field of neuroscience and what makes his field so particularly difficult. We go into topics covered in his books. We discuss presentism versus eternalism. If you don't know what that means, don't worry. When we get there in the podcast, you'll understand. We discuss mental time travel, prospective timing versus retrospective timing. So prospective timing is when you're in the moment, how time passes for you. Retrospective is how you remember how the time passed. Don't worry, guys. He'll explain it very well. It will make sense when it gets to it. We discuss religion and fear of death. We discuss drugs, isolation, meditation, hypnosis, and of course consciousness and free will. I have to bring it on. If I bring a neuroscientist on, I have to ask them about consciousness and free will. I can't help it. What else? And yeah, I hope you guys enjoy the episode. If you guys have any suggestions for future episodes, you can find us on @big_topics on Twitter. One new announcement, I would say, we have a Patreon now. You can, if you like our podcast, you can support us on Patreon. Links will be in the description. Yeah, so obviously the podcasts are free for anyone, but if you like what you see, you can drop us some few pounds a month. That would be really appreciated. And there will be perks that come with it. So Um, there are like 3 tiers which you can join with different benefits. One of them, you'll get a Little Brains Big Topics exclusive cup. That's a very interesting one. Yeah. So hope you enjoyed the episode. So thank you very much for accepting our invitation. First of all, so could you tell us about Your Brain is a Time Machine and what motivated you to write the book?
Sure. So neuroscience, of course, is the study of the brain, and I think the brain is an inherently temporal organ. And I say that sort of literally and figuratively for 4 reasons. So first, in many ways, the brain's main function is to use the past to predict the future, right? We think of memories. We think memories, well, we can relive past experiences, but that's not the function of memories. The sole function of memories is to allow us to better prepare for the future. So that's number 1. Number 2, the brain provides us with a means to engage in what's called mental time travel. So part of predicting the future is being able to simulate different futures, to say, okay, well, you're preparing for this podcast and you're thinking out the questions beforehand. So you're simulating different future scenarios. What are the best questions? So that ability to simulate the future is indeed something that gave humans, Homo sapiens, a huge adaptive advantage over other animals. Number 3, more on the philosophical basis, the brain somehow endows us with the ability to feel time, to perceive the perception of the flow of time, which is part of a fundamental part of human existence, right? Our conscious experiences are anchored in the flow of time. And there's nothing really, it's hard to imagine consciousness itself without that. And finally, the brain is a machine that tells time. The brain evolved mechanisms to tell time, just like humans have, since the dawn of technology, been inventing clocks to tell time. The brain has evolved ways to tell time at the neurobiological level. And so together, those 4 reasons really point to the issue that without understanding how the brain tells time, we won't understand the brain and we won't understand the mind.
So by referring to the brain as a time machine, are you more referring to the brain being like a clock as opposed to an actual sci-fi time machine, I guess?
Yeah. I mean it cohesively, all of those. So the brain is a machine that tells time, right? So clock is a machine that tells time. So in that sense, the brain is a time machine, but it's also a time machine in the sense that it allows us to travel in time. So time machines, as in science fiction, will almost certainly never exist. But your brain is the closest to a sci-fi time machine that you will ever have. And it's an ability that is fairly unique to humans. You can easily travel back in time mentally to think about your an old birthday or old events that were of significance to you, and you can imagine different potential futures. And that ability, called mental time travel, is absolutely fundamental to our species. You think about something like the invention of agriculture. That's an ability that's beyond the cognitive capacity of most animals. And it requires mental time travel, right? Because you need to plant a seed today, and you have to be able to see that the benefits of planting that seed today are going to be available in the future. The advantages of that are going to be future oriented. Over a span of months or even years. And that's something that most animals cannot really grasp.
Whilst we're on mental time travel, I was wondering, do you think so? It seems to me, and correct me if I'm wrong, it seems to me that humans suffer more than any other animals. Or do I don't even like I'm not even sure to what extent other animals suffer. And I think the suffering, the human suffering is us being able to time travel into into some bad time period in the present and just stick there forever. That seems to be um, what's uniquely human. I want to just get your thoughts on this.
Yeah. So you're hinting at the fact that maybe it's because we can have the capacity to engage in mental time travel that enhances suffering,
Yes.
because we can suffer prospectively or in anticipation of events. We can look back and remember having a loved one that has died. We can exhibit prospective regret for somebody who might be dying or might be suffering, or for a family member who's struggling with cancer or undergoing surgery. So a couple of things. So first, I think most animals, at least most mammals, suffer, but they suffer in the present. So if an animal's in pain or hungry or injured, I think that's, evolutionarily speaking, a shared form of suffering. Suffering is a flavor of consciousness, if you will. And I think that most animals live in the present, and humans do too, and we suffer in the present as well. But indeed, I agree that humans have a higher order level of conscious experience, which also extends to suffering. There's a great quote by Jorge Luis Borges that says, all animals are eternal because they are unaware that they're going to die. And so our ability to engage in mental time travel led to what must have been a very shocking and depressing realization, right? That we're mortal and that we will die. And that, in a way, I think might be a bit what you're getting to, can induce some degree of suffering. Now, some would argue that that went hand in hand with the invention of religion, that when we realized that we were mortal and we developed this ability to see the future and thus see our own transient, that we invented religion as a way to cope with that.
Yeah, and it's definitely I can see it whenever like I talk to my friends about like the concept of dying and death. It seems something very hardwired in us that's disturbing us, that um we can't contemplate not existing in the future. And I want to get your thoughts on this. So last week we had Craig Callender on. He's written a book on philosophy of time, basically. And
Absolutely. No, correct.
do you know him?
Yes.
Oh, great.
Great. Yeah.
And he was saying that one of the mysteries is essentially that we don't know. So we're not afraid of our prenatal not existence, but we're afraid of our post birth non-existence. So why do you think that's the case?
Yeah. So there's a huge temporal asymmetry, right? So we were very preoccupied with the fact that maybe I'm not going to be alive in 20 years, or that I'm going to suffer because some upcoming event, maybe because I'm going to get sick with COVID. But generally, the past suffering isn't something that bothers us as much. I'm worried about not existing 100 years ago, 100 years from now, but But most people aren't worried about the fact that they didn't exist 100 years in the past. So yes, there's this huge temporal asymmetry. I think that's largely just a consequence of evolution, right? Evolution is for future oriented. This is it's as Craig no doubt alluded to, there's this interesting tension between the physics of time and the psychology and neuroscience of time. So in physics, it's valid to ask questions about, well, if the past is as real as the present, which is as real as the future, and if it's theoretically possible to alter the past or to or why we don't remember the future. But evolutionarily speaking, the brain is very future-oriented, and evolution is very future-oriented. So it makes all the sense in the world that the brain, as a product of evolution, is worried about the future more than the past. Because if you've arrived at that point in time, it doesn't matter how you got there. What matters is your chances of survival from that point on. You imagine in the game of chess, you imagine the position on the board. There's many trajectories to get to that position on that board. So suppose you're in a mid-game in a chess. So there's pieces on different positions. There's many ways to get to that different position, right? There's many paths that could have led to that. But you don't need to know those, right? From that point on, all you need to know is look forward. How you got to that position is actually rather irrelevant. From there on, to make the best decision, you just need to look forward. So I think evolution, because the brain is a future-oriented device, a future-oriented computational device, as is evolution, I think it makes sense that we have this temporal asymmetry.
Before going into some more specific questions with regards to your book, can I just ask you about your field of neuroscience and what has the arc of progress been like in the recent decades?
So let me just elaborate that a bit more generally. Scientific fields evolve and mature. And part of that maturation process, part of that developmental process is, in my opinion, to slowly incorporate time. If you look at what was probably the first field of modern science, that was probably geometry. Geometry is one of the few things that we teach children today, say Pythagoras' rule, that was known 2,300 years ago, right? So there's not many things that fall into that category. So why was geometry the first field of modern science? Well, because it had no time. Geometry is a study of a universe without time, just static objects, at least Euclidean geometry is. So it took another 1,500 years for people like Galileo and Newton to bring time into physics and mathematics. Neuroscience, I think, is going through a similar developmental process. So it's only in the past decades that I think neuroscientists have really begun to appreciate how fundamental time is to understanding the brain and understanding the mind, because its main function, as we just said, is to predict the future, anticipate events, and so forth. So historically, the field of neuroscience has asked the question of how does the brain tell time? One of the ideas going back to the mid 20th century is that you might have a central clock in your brain, and that central clock might be responsible for timing on the scale of milliseconds, seconds, hours, and days, which is a bit like a wristwatch, right? So you have a wristwatch, amazing piece of technology, a wristwatch, right, that has a millisecond digits, and it has years, the same device. So it was thought that the brain might have a centralized clock, and that maybe that clock worked like man-made clocks in which you had an oscillator ticking away and some other system integrating that across time. We now know, so some of the advances we've had over the past 10, 20 years is that the brain does not have a central clock. The brain has many, many clocks, some specialized for microsecond processing, for example, detecting the sound, time it takes sound to travel from my right ear to my left ear. Millisecond timing in speech and music is a different mechanism. Many seconds and minutes seems to be different areas. And of course, you have the circadian clock, which is the systems in your brain that tells you when it's time to go to bed, when it's time to get up, when you're hungry. And that clock, your circadian clock, doesn't have a second hand. It just has an hour hand. You have other clocks that have second hands but no hour hands. So it's very different from man-made clocks. So the field of neuroscience has now reached a level where we have at least that level of understanding, but there's many, many, many open questions in how the brain tells time and represents time.
Yeah, the reason I asked this question is I don't, you know, Matthew Cobb recently, he's from University of Manchester. Yeah, he recently wrote a book about past, present, and future of brain. It was something along those lines, and he was basically saying that he had this PhD student working on the belly of a lobster for 30 years, and the lobsters apparently only have 30 neurons in their stomach, and basically after 20 years of studying they couldn't figure out how the neurons interacted with each other, which so I don't understand. If we can't tell how the belly of a lobster work, how can we dare to ask any deeper questions, such as about the nature of consciousness?
Yeah. You have to be careful with what you mean by understand. So it's a mistake to think that when we're asking a scientific question, there's one form of understanding or one answer. Let's say you believe you accept evolution. Do you understand evolution? Do you know what the sequence of mutations were happened to generate Homo sapiens? Do we know which mutations happened between the common ancestor between humans and chimpanzees? The answer is no. But do we understand evolution? Well, yeah, we understand evolution at one level. It's not that complicated. You have random mutations, and those mutations that provide selective advantages improve. So now, going to neuroscience. It's absolutely true that there's, quote, simple systems. You're referring to the somatogastric ganglia of lobster, which have not a huge number of neurons, but have complex interactions. So a mechanistic mapping of each one to each one, true, we don't understand, but conceptually we do. I mean, we have a reasonable understanding that some combination of those neurons are responsible for the digestive actions or peristaltic movements and so forth. There's different behaviors, there's different modes of operation. And we know they have something to do with different neuromodulators that change the state of that system. But true, we don't understand the details, but we have a view of the big picture. Let me give you another example. Today in deep learning, we have these networks that are man-made that can do facial recognition or speech recognition. If you ask somebody in computer science or machine learning, do you understand it? And one answer is no, and we made it. You know of AlphaZero, a computer that plays chess better than any other computer or human on the planet. Do we understand how it does it? No, not really. But did we make it? Do we understand the principles, the algorithms that allows it to learn? Yes, we do. So the brain is no different. You need to be careful with what you mean by understanding, and there's different levels. It's okay to say that we understand the principles, but not the details. And other times we know the details, but not the principles.
Very interesting. And what is it that makes neuroscience such a difficult subject to study?
What do you think, Mohammed?
I'd assume the complexity of the many. If we can't understand 30, then how many ever billions we have in human brains?
So the complexity is certainly part of the issue, right? But there's a much deeper issue, which is neuroscience is very unique field of science. Neuroscience is the only field of science in which the thing being studied is doing the study.
Oh.
So never forget that fact. So that makes your neuroscience absolutely unique among all fields of science. And it's reasonable to ask if that's even possible. Can any system understand itself, especially if it didn't evolve to do so? So you need to be humble and say that maybe we can't. Maybe we can't understand ourselves. Maybe we can't understand the brain. I don't think there's any reason to think that's true at this point. But I think we have to be humble in our approach and say that, remember that we're trying to understand something using the thing we're trying to understand. So it didn't evolve to do that. So neuroscience is a unique and challenging field because of its recursiveness. It's trying to understand itself.
So in a sense, we're sort of so an AI designated to survive, basically, right? A sort of computer evolutionary program just to pass on its genes that all of a sudden is starting to asking questions about itself, but it wasn't designed to ask. It's the faculties don't exist. So
Absolutely.
right.
It's really quite amazing that we've made it this far. As you've said, the brain evolved to provide our species with an ability to reproduce and thrive in a world, in a natural environment that might have been the steppes in Africa. And the fact that we've now sent people to the moon and decoded the human genome is just absolutely astounding. But that doesn't mean really that we're particularly intelligent, or we're I think you could say we're the smartest species on the planet, but you could also say we're the least stupid species on the planet. And it remains an open question about if the brain is really capable of understanding itself.
And do you think this limitation might be existing in other sciences as well? So could there be things that we take for granted in other sciences that are just our conscious biases?
I think the limitations of the human brain are certainly relevant in other fields. A classic example is physics. So the human brain evolved to make sense to survive in a world governed by the laws of physics. Now, to survive in the world that we evolved in, it needs basically to understand sort of Newtonian physics, how things fall, how things move, and velocity, acceleration, and so forth. Understanding quantum, having a good intuition about quantum mechanics or cosmology isn't very important for survival, which is why we suck at it, right? We have a terrible intuition of quantum mechanics, right? It doesn't make any sense to try to understand how a particle can be both a wave, how a specific particle can both function as a particle and a wave. But it's not surprising because we didn't evolve to do that. The brain is a computational device that has simply didn't evolve under those selective pressures any more than the Alpha Zero, which was taught to play chess, is capable of driving a car. So yes, I think physics is constrained, our understanding of physics is constrained by the architecture of the brain. I think, fortunately, that's not it's a severe limitation in the sense that we don't have a good intuition. But fortunately, we have mathematics, and mathematics is a way to describe the universe, whether we really intuitively understand it or not.
I want to ask you about the concepts of presentism versus eternalism. So first of all, did you give them those names, or did they exist beforehand?
No, they absolutely existed before. They've been around for many decades, in terms of two different views of the nature of time. And under presentism, the view is that only the present is real, the past no longer exists, the future does not exist yet. And under eternalism, there's nothing special about the present. The past, present, future are equally real. Both of these are sort of simplified caricatures of different views of time, but I think they're nevertheless important.
So presentism is our existential reality, right? It's how we arrange our societies. It's based on the assumption of presentism, essentially, isn't it? Yes.
So implicitly, intuitively, most people accept the view that only the present is real, and the past is no longer real. It does not exist, and the future does not yet exist. It is no longer real. So that's certainly the common sense view of time.
But eternalism is, well, our objective understanding of physics is telling us that eternalism is true. That there is no now, there is no past, it's just like the space and time are essentially the same thing.
Yeah, you have to be a bit careful with saying they're the same thing, but they have a commonality in that they're true physical dimensions of the universe, or fundamental features of physics. So physics does not suggest that there's anything special about the present. There's no equations in physics that say now is important, or now you can run the equations forwards or backwards and they work equally well. Relativity tells us that clocks change at different speeds. Relativity tells us that clocks change at different rates depending on their speed or their gravitational potential. So that means there's no absolute present. You can have two clocks and one goes this way, this one come back. And where they were synchronous originally, now they're not. So time changes at different rates. So physics, the laws of physics seem to be telling us that, suggesting something that's consistent with eternalism, and sometimes called the block universe, in which the universe is a four-dimensional block where the past, present, future are equally real. Now, but there's a lot of interpretations of that. And different people will give you different answers of whether that's what that means, how to interpret that. Now, my view is that our intuitions that the past doesn't exist and the future is not yet exist do actually reflect something true about the universe, and that we do not live in the block universe. It's an experimental fact that time changes at different rates. But I think the conclusion is that now is a local phenomenon. So it doesn't make sense to ask what time is it now in a different galaxy. That question doesn't make sense. Because now just refers to a local aspect of your environment. And I think that's the lesson from relativity, not that eternalism is correct or the block universe is correct.
Right. And do you think there is some fundamental reality to the concept of now? Or could it be just a creation of human consciousness?
Not sure if I quite get the question. I think now is a subjective, in one sense, now is a subjective feeling. We all know what that means. I don't think it's a physical. It's a property of physics. I think it's in a sense creation of the human mind, but in a sense, it's just now is defined by the state of a physical system, and that physical system could be a clock, and that state can be comprised of the now. It's continuously evolving. A clock, imagine a clock sitting alone in the universe, and it's continuously changing. As far as that clock is concerned, the state of the clock at that given moment, and here the language is a bit complicated, is defined by its now.
Right. So you don't think the block universe is shows the whole picture?
In my view, I don't think the block universe is a requirement of what we know of the laws of physics. I think it's the interpretation that best matches how our brains work, given what we know about the physics. But I think that our subjective sense of the flow of time is true, and our subjective sense that the past, the local past, is no longer exists in the universe reflects a physical reality.
So what are the ways we can sort of manipulate people's perception of time passage? Yeah, that's my question.
I mean, I don't know if whether you're manipulating or not. I mean, everybody's familiar with the subjectivity of the flow of time. We all know, we've all experienced the fact that time seems to flow very quickly when we are engaged in a fun activity, when something is cognitively engaging. But if we're bored or time's going, then we feel time going slowly. A lot of people report this during the pandemic, in that if you've been home a lot alone by yourself, time seems to be dragging or going by very slowly, importantly, prospectively, right, as it's happening. So there's an important difference between the prospective feeling of the flow of time and the retroactive flow of the retrospective or retroactive flow of time. So if you've been doing that home alone all month because you're under social isolation, at the end of the month, it might feel like it went by very quickly. And that's because retrospective timing is in many ways more related to how much memories you've stored during that period of time. So there's many examples of this. The great psychologist William James, pointed out that if you're homesick for a week, as it's happening, it might feel that time is going by very slowly because you were very bored. But after it's over, it might have seemed like it flew by because you have no memories of what happened. But if you're on vacation for that 1 week in which you're having a lot of new events and engaged, then it might seem like it's flying by as it's happening. But retroactively, it seems like it lasted a long time because you have a lot of new memories that were formed and you have a feeling of having accomplished a lot. So retrospectively, it seems like it lasted a long time.
And why is it that every time we're having fun, it goes by quickly? What's the neuroscience of that one?
We honestly don't fully understand. We don't know. So we're only just beginning to learn how the brain tells time. And now this is a question on top of that, right? So why do the brain's internal clocks seem to go quicker or slower under some circumstances? One can imagine that the clocks in the brain have variable speeds. So if you're engaged in an activity, then the clock will slow down. So when you're engaged in an activity, the internal clock might slow down. So that means that if your internal clock is going slow, the external clocks seem to be going faster. Thus, time seems to be flying. You can imagine that that mechanism evolved because it's important to encourage animals to engage in activities that are beneficial. So if something is flying by, like maybe you're having fun with friends or you're eating a good meal, those things are presumably adaptive for you. They're advantageous for you. They should be encouraged. So by making time fly, you're encouraging people to do those. Nobody likes being bored, and that's not a good use of your time. So that type of feeling bored is a negative feeling. So then that would be discouraged by evolution. But as I said, we don't really understand the mechanisms of the brain's clocks or how their speed changes well enough to really answer that question.
And I've also heard you talk. No, I've read in your book about caves and isolation and its impacts on perception of time. And apparently, if you're in isolation, your perception of time, again, I might mess it up, it's going to speed up relative to objective clock, isn't it?
So yeah.
Why is that the case? Because I thought, oh, surely it's the opposite. Surely if you're in constant pain, you're confused. Surely you're gonna feel longer than it would have been. So
yeah. So there's a couple of things going on there. So yes, first, yes, they back in the 70s they did a lot of experiments with the perception of time and social isolation, either by people volunteering and spending months in caves or in isolated bunkers or basements. Now, you have the circadian clock, which tells you how many days have passed. And one thing that happens is the circadian clock under social isolation, the phase of the clock, or the cycle of the clock, the period of the clock, actually prolongs. So instead of being close to 24 hours, it might be a bit above. So in that sense, it's the case that if somebody was going to stay in the cave for 6 months, and they have no ability to tell external time, when they finally came in to get the person, the person was often surprised. Oh, it's already 24, it's already 6 months. So in that sense, their internal clock was actually slower because they were counting. They might have counted 5 months, but actually 6 months have passed by. Now, again, that's in part due to the slowing of the circadian clock, but this perceptual feeling of boredom is a bit different, right? I mean, that's sort of just prospectively. And again, remember that what we talked about, the difference between prospective and retrospective timing. So because not much happened while they were in the cave, they might not have had very many memories, so it might have seemed to go by quickly retrospectively. But again, I think it's too complicated to attribute to one mechanism here.
Right. And so let's say I want to I want to feel like I've lived a long life. What should I do?
Yeah.
Yeah.
Perfectly valid question. And most of the time when we ask that question, we're saying retrospectively, like we want to look back on time and say, that was time well spent. I've had a productive life, or I have a productive retirement. And, there's many self-help books and tips for that. And I think most of them make valid points. Most of them is to be engaged in things you enjoy doing and continuously learning and continuously engaged in novel activities like starting your own podcast, maybe. And that means that you're meeting new people, you're learning new things. And so those are forming memories. So when you look back, absolutely, you should have more of a sense that something was accomplished and that time seemed to be well used, as opposed to just doing the same thing day after day after day with nothing new. That will not form many new memories. And when you look back at that, time will have seemed to have gone by very quickly, retrospectively.
What do you think of the impact of drugs on our perception of time? Does that tell us anything about how the brain tells time? The fact that it can be manipulated so easily?
Sure. Yeah, there's a lot of studies of sort of chronopharmacology, of how pharmacological state affects our subjective perception of the flow of time. And people have done studies both in humans and animals. The studies are actually hard to rigorously interpret at this stage. I don't think the data is particularly clear, but one of the common reports is drugs like THC, or the active component in marijuana, that causes people to feel that time is going by slowly. And numerous studies confirm that in humans and animals, in which so time is going by slowly, okay? So that would be equivalent of the internal clock speeding up, because let's say your internal clock has hit 5 minutes because it's going fast, and then externally you look at it and only 2 or 3 minutes have gone by. So external time seems to be going slowly, means your internal clock is going faster. And so that indeed is consistent with some pharmacological studies in both humans and rats, where they'll train an animal, or they'll ask a human to time out 60 seconds, and then they'll be given THC. And now, instead of timing out 60 seconds more or less accurately, they might say time 55 seconds. So as an indication that their internal clock might be going a bit faster. But again, why that is, what are the mechanisms of that, if that's literally accelerating the speed of the timers, the neural timers in your head, is not clear.
And I was wondering if you had any thoughts on the states of meditation and hypnosis. When people go into those states, their time. I'm just trying to think whether it slows down or speeds up. It is speed. So you feel like 10 minutes has passed, but in reality, it's been 1 hour. Yeah. And my dad, as a clinical psychologist, he regularly does hypnosis for treatment on people, and that's like a consistent result he's been getting. And there are many other studies on that. So do you have any thoughts on why that's the case?
So I think that's similar to in hypnosis or meditation being a positive state or state of positive valence in which you're sort of equivalent, if not necessarily having fun, but being engaged, right? So, I mean, if you're reading a good book, or if you're a computer programmer and you're very cognitively engaged in that task, yeah, maybe an hour has passed and you feel like it's only been 10 minutes. So one interpretation of that observation of subjects that have undergone hypnosis or meditation is that by not paying attention to time is equivalent to the clock maybe here now going slower because you think 10 minutes has passed, but in reality it's been an hour, so your internal clock is now going slower than the external clock. And if that's prospective or retrospective, I think it depends case by case. I think normally it's when somebody's asked, okay, well, how long were you meditating for, or how long were you under hypnosis? And they tend to underestimate that. Is that the observation that you're familiar with that? So as
Yes,
maybe
yes.
a session that lasts an hour, maybe they'll think 30 minutes has gone by.
In fact, I've done it, so I.
Yeah. So you've had, what were the times? So it was like an hour or 30. What?
Yes, it was around. It had taken about 45 minutes, an hour, and for me it felt like 5 minutes, 6 minutes.
Yeah. Interesting. So that's very radical. So it's hard to believe that that's due to acceleration of the clock. It's hard for me to imagine that a clock, or slowing down of the clock, I should say, is slowing down that much, because most neural processes aren't modulated that. So I would say that's probably more due to your psychological state. Maybe by not paying attention to time, it's equivalent to doing something that's highly enjoyable. But all these questions are very important, but we don't have the tools yet to really understand them. And you can imagine that they're tightly coupled to consciousness, right? So it's almost hard to dissociate the subjective flow of time with conscious states. I mean, as a trivial example, suppose during those 45 minutes you happen to fall asleep a bit. Right? Then obviously, yeah, time will seem to have gone by very quickly because you're sort of lost consciousness and then came back out of it. So when we've all been there too, right? Where you fall asleep, you don't really notice. So it feels like you're surprised that an hour has gone by. And since we don't understand consciousness at all, it's very hard to answer these questions scientifically at this stage.
And I really appreciate you raising that question in your book, because I think it's the first time I see someone trying to have time as a fundamental aspect of consciousness, because I hear a lot of people talk about consciousness, but rarely in the context of it being a tool for interpreting time.
Yeah,
I really appreciate it in your book.
Yeah, thank you. I think I think they're almost dissociable, almost undissociable. So I think it's going to be very hard to understand subjective experiences of time in particular without really knowing what consciousness is.
And what are your thoughts on free will?
Yeah. I think there's a lot of, just like you said, there's a lot of talk about consciousness, or a lot of discussion of the neural base of consciousness. You know, free will, there's few topics that have generated as much debate and confusion as free will. And I think, unfortunately, a lot of that is just caused by people not bothering to define the term. So you just asked me a question, so I'm going to ask you back. What do you mean by free will? Define what you mean by free will.
Right. Yes. I thought I might get into. I've got myself in trouble. I say usually people think they have agency over what they do in their lives, right? So when I say, okay, this morning I woke up and chose to brush my teeth, but I could have chosen not to brush my teeth. It was equally possible for me not to do that. But then, was it? Or maybe it was meant, you were pre-programmed to do that, but you just felt it was just a feeling that you decided.
Okay.
And apparently there are some experimental studies, like some split brain, some other ones where they can predict which button you're going to press with some accuracy before you think you've decided. Um, so
Yeah.
yeah, I think we don't have free will, the type of free will people think, but I'm really curious to get your thoughts.
Yeah. So I think it is, the most important part is to define what we mean by free will. If you mean by making a choice, of course we have free will, right? Because we always make choices. Now, if you mean making a choice that's not governed by the laws of physics or by the processes in your brain, well, scientifically, of course, we don't have free will. Because, of course, everything we do is governed by the laws of physics. So some people, I think, equate free will with essentially magic or supernatural beliefs or a soul, and that there's something else that's making those decisions. So scientifically, we can say, no, that's not the case. So if you're going to define free will by something that's governing your decisions that's outside of science or outside of physics and neuroscience, then no, we can say we don't have free will. But I don't think that's productive at all, because that's not scientific. Now, if we define free will, I think there's two ways I prefer to define free will. Free will is this feeling we get when the brain makes decisions, whether it's conscious or unconscious. If I decide to have a sandwich for lunch or a salad for lunch, presumably my brain made unconscious decisions, and then that unconscious decision was elaborated into a conscious domain that I became conscious of, and I felt like I made that decision. Now, so to me, free will is the brain making decisions, whether it's conscious or unconscious. I think people are uncomfortable with the notion that free will is unconscious. And I've never really understood why. My brain is my brain. It doesn't matter if it's conscious or conscious. Who I am is the sum of my conscious and my unconscious brain. So the fact that it was made by an unconscious circuits within my brain doesn't affect at all the fact that it's not mine, right? Still, I am my brain. I think people often mistake or are comfortable with the notion that they are an unconscious being. But most of our decisions are unconscious, right? I'm not thinking about which syllables to use when I speak to you. And by most accounts, I'm probably not thinking at all consciously about what to tell you. I become consciously aware as I'm already saying it. So I think once people become more comfortable with the idea that the brain is largely an unconscious device and our decisions are largely emerged from unconscious neural processes, that the mystery of free will becomes much more understandable and less mysterious. Now, you asked about, again, continuing this line of free will, and in some cases, in experiments, it's possible for investigators to record from your brain and ask, well, can you press this button whenever you want? Exert your free will. And in some cases, and there's a bit of controversy on this topic, it's possible to predict before you respond that you will respond, or before you seem to be aware. That's entirely consistent with what I just said. Your brain makes unconscious decisions, and it engages those mechanisms, and at some point they become conscious. But the feeling of free will is just the transition from the conscious decision to, the transition from the unconscious decision to the conscious decision. And that's the way it has to be. The brain is simply a computational device made of neurons. At some point, those neurons must reach a state in which a certain decision or action is undertaken, and at some point, that becomes a conscious feeling.
So you think your unconscious decision making is still your brain? Therefore, what your brain does is you. So free will to some extent.
I think that's the free will I believe in. That my brain is my brain. It's conscious plus unconscious, and the unconscious brain makes decisions. Sometimes in interaction, sometimes by itself with the conscious brain. And free will is the action or the process of having those decisions made, decided upon, and executed. So I don't think there's, in my mind, there's no particular mystery there of free will. Let me give you another example as a metaphor. The metaphor of if a tree falls in the forest and nobody's there to hear it, does it make a sound? It's an old riddle, I think, right? An old Zen riddle. And it's a silly riddle. It just depends on your definition of sound. If you define sound as somebody, a human being, hearing it, then of course it doesn't make a sound. If you define sound by vibrations of air molecules, of course it makes a sound. So you just need to choose your definition of free will, just like you need to choose your definition of sound. If you gave me a definition of free will earlier, and yes, it's the act of making a decision to brush your teeth or not. So of course you have that free will because you do it every day. There's no mystery there. The mystery is how that comes about, but that's a computational problem.
And are there any upcoming research you're looking forward to?
Always, nothing specific that I think is worth getting into in detail. The research in itself is highly specialized, and I don't think it's particularly of interest to the general audience because it's often so specialized. But I think in the upcoming years, a better understanding of how the brain tells time is something that we'll achieve little by little.
And final question, has your study of the brain and time had any impacts on your personal view of life and what it means to be a human?
Yeah, that's an interesting question. My view of time is really resonates with the importance of time in neuroscience. And nothing is more important than time in life, right? Life is time is the currency of life. We struggle for more time. We wish we had more of it. We have a limited lifespan. So it really emphasizes or highlights the importance of time in neuroscience and the importance of time to our own personal lives, and how valuable it is and how mysterious it is. And as we struggle to understand the nature of time, we also struggle to do the best with the time we have, each of us has while we're on the planet. And let me just finish there then. Human beings are highly unique in our ability to engage in mental time travel and to think about the future and to act prospectively. But that doesn't mean we're good at it. And for the most part, we're unique in that ability, but for the most part, we're actually sort of bad at it, and we don't do it enough, right? Maybe we don't exercise enough, maybe we don't save enough money, and maybe we don't take as much care of the environment as we should. And we struggle to do things like engage in the necessary actions for climate change to counteract climate change, because it's something we struggle with long-term goals. So time is, an understanding of time is critical for taking long-term actions to ensuring that each of us has more time on Earth, and that our fellow human beings have more time on Earth as well.
And on that note, we're out of time. So
there you go. Damn it.
Thank you very much for your time. And
it's my pleasure, Mohammed, and thank you for your time.
Great.